My name is Marcelo Santos, and I'm a professor of geodesy at the University of New Brunswick, Canada. This is a series of 5 videos in which I overview 5 climate-related news published in February this year in such a way to highlight their importance. In this video, we will talk about was January 2020 the hottest January month ever? January 2020 was the hottest January ever. That is what newspapers said, quoting NOAA. But then, NOAA very carefully comes with a caveat ignored or not understood by the media. Global land and ocean temperatures at least nominally above the 20th century average. What does that mean? It means that the oscillation in global temperature from year to year are tiny small. If we perform a statistical test on them, we conclude they are statistically equivalent. It is better to look at trends, preferably over a long term. What about the trends? The trends, as evaluated by NOAA, indicate an increase in temperature equal to plus 0.18 degrees Celsius per decade. It is always good to compare with alternative sources. The upward trend estimated from 4 reanalyses of numerical weather prediction models is 0.15 degrees centigrade per decade, and those estimated from remote sensing satellites is 0.12 degrees Celsius per decade. These trend values are less than what we regularly see quoted by the media. Nonetheless, they indicate on average an increase of 1 degree Celsius by the end of the century. Going back to the hottest January ever, the enormous empties in land-based meteorological stations, not just in the oceans but also in huge land areas, result in lack of data which has to be filled by model data. A more realistic way is to use actual temperatures observed by remote sensing satellites. The map shown was produced by satellite data from the University of Alabama in Huntsville. In it, we can see the last cold winter experienced over Hudson Bay, over the Baltic countries stretching over Eastern Europe, and the area over Manchuria and Siberia, as well as the colder winter experienced in Alaska and in Greenland and other portions in the Middle East and Asia. This map is much more complete than the NOAA map, which lacked Greenland and painted red the whole area from Siberia to Europe. I plan to produce a video dedicated to temperature trends and problems with legacy measurements, but let me end this video showing a temperature set that I particularly prefer, the ones coming from remote sensing satellites, as they are unaffected by ground-based effects. This one is the temperature anomaly of the lower troposphere. In this context, an anomaly is the difference of measurements with respect to a reference value, in this case, the average from 1981 to 2010. We can see the peak in temperature anomaly in the 1997-1998 and in 2015-2016 due to El Niño, a warming of sea surface temperatures over the tropical eastern Pacific Ocean. The figure shows the global average lower tropospheric temperature LT anomaly for January 2020. It was plus 0.56 degrees Celsius, unchanged from the December 2019 value of plus 0.56 degrees Celsius. January was indeed one of the hottest months since 1979, as hot as December 2019 and less hot than a few other previous months. While preparing this video, I learned that the global average lower tropospheric temperature LT anomaly for February was plus 0.76 degrees Celsius. A continuing weak El Niño conditions, on top of the long-term warming trend, are likely responsible for the current uptick in temperature. And let me make myself clear. We need to fight pollution, the real one, for the simple reason that this is the air we breathe, the water we drink, and the soil on which we grow our food. We depend on them. We cannot poison them.